Hello and welcome to Serverless Office Hours. I'm so excited to be here. That's a pretty long intro. We may have to cut that down. I was like, wow, that's like 30 seconds there, but we're here. I am here with Uma and Ji Young. And I'm going to ask you here publicly, Ji Young, am I saying that properly?
Yes,
All
you
right.
did that exactly.
Yes, I love it. I love it. I'm very happy about that. Uma, am I saying that properly?
Yeah, I'm Uma,
Okay.
not
Oh,
Yuma.
oh,
Uma.
oh, okay. Oma. Oma.
Yeah,
Okay.
yes.
My name is pronounced Eric. So
Eric.
there you
Yeah.
go. We got this. Okay. Today we're talking about step functions and containers, which I got to be honest, this is one of my most favorite topics. I'm kind of new in the containers world. Ju Young knows this because she's had to kind of carry me a little bit, and Uma has carried me a little bit on this as well. And I've been learning this. And it's a lot of fun. But before we jump in, real quick, tell us who you are and what you do at AWS. So we'll start with Uma.
Thank you,
Uma.
Eric. Hi, folks. My name is Uma Ramadas. I'm a specialist solutions architect on serverless. I'm based out of Atlanta. I've been here with AWS for more than 4 years now. I joined as a specialist SA on serverless, but like just after that, I started supporting or covering managed airflow. For 2 years, I supported managed airflow. That actually helped me learn about workflow management, data processing, etc. And now in the recent times, the last 1 year or so, I've been again with serverless customers, helping them through their serverless journeys with a special focus on workflow management and event-driven architectures. That's about me.
Wow.
Outside of outside of work, I have two little boys. They are like at the stage where they demand a lot of my attention. So it's work and family. That's it.
Nice, very nice. Yeah, Jiyoung.
Yeah, I think I'm next. Hey, folks. This is Jiang, and I'm specialist solutions architect for the container. And then my main responsibility is focusing on the ECS Fargate. But of course, I know the EKS and the Kubernetes as well. But at this moment, my priority is more on the serverless computing portfolio, which includes the Fargate and the Lambda as well. And I have been AWS almost 5 years. And then, yeah, happy to talk about the step function and the Fargate. So, yeah, that's all for me.
Nice, love it. Now I want you to know, Jiyoung, that while I'm learning ECS, I can't even spell EKS, which is the joke I always use. But there's a lot of truth there, so that'll be our next journey together. So super excited about that. Okay, so if you're not familiar with Service Office Hours, this is an office hours. We obviously we're going to be presenting something. We're going to be showing you some techniques with today focused on step functions and containers. But this is a place for you to ask questions as well. And no question is too silly. You'll find I'll ask a lot of questions that you're like, really, you should know that, Eric. But we ask it anyway to find out. So ask your questions in the comments. Also, post where you're coming from. We love to know where people are watching from, and we love to hear from you. But with that, we're going to go ahead and get started. I think Uma, you're going to be sharing first. Are you ready for me to bring that up?
Yes.
All right. Okay. Here we go.
All right. This group doesn't need an introduction to step functions, but for the completeness sake, AWS Step Functions, it's a visual workflow service. Our customers, build workflows of like several different types, and I've seen customers build microservice orchestrations within distributed applications, business critical applications, data processing pipelines, and even these days, like generative AI workflows are also coming up so often with step functions. They love the simplicity. They love that it is serverless. It gives, out of the box observability, auditability, so many good things, and so they really love step functions simplicity. What today, Eric said we're going to cover step functions plus containers. And yes, we're going to cover step functions and containers. But for simplicity's sake, we're going to take ECS as a primary example. So all the slides that we're going to have will have ECS as an example. I do have a demo at the end to show like how the step functions integrates with ECS with one pattern. And so that, also primarily on ECS, but the integration with EKS is very similar with little nuances, and here and there we will cover that as well. We have a ECS specialist, so I don't want to take much time from her. She will cover the ECS part. Couple of slides.
Okay. Yeah. So since like Uma said, today's session focuses on step function and then ECS with Fargate. Therefore, I would like to briefly explain what is a ECS and a Fargate. We can say ECS is a serverless container orchestrator because it's fully managed by AWS. This is because ECS doesn't have cluster version and not data to maintain or scale. And when it comes to Fargate, Fargate is a serverless compute engine for container. So with Fargate, you don't need to think about provisioning, configuring, and scaling of your cluster capacity. And then Fargate take care of all of the infrastructure management for your tasks. So Fargate is, and then the Fargate is composed of isolated VMs, which prevents interference from other applications and minimize issue through automated patching. And additionally, with granular resource allocation, Fargate can also offer significant cost optimization benefits. Next slide, please. And then as you can see in here, there are three key components when it comes to ECS. So that is the cluster, service, and task. So think about it. When you're trying to build some of the workload on the top of the ECS, then at very first, you're going to create the ECS cluster. And then second thing, you're going to create the ECS task definition. In there, you are going to specify which container image are you going to use, and then how much resources are you have to allocate it. And then you can put some of the environment variables or other Linux capabilities into there. And then after everything is prepared, there are two ways to deploy ECS task to your ECS cluster. So one is, as you can see in here, creating a service, and the other is running a standalone task. So standalone task allows you to execute the task without the need for the long-running services, which is ideal for short-lived or one-time jobs. So I would like to say standalone tasks are suitable for workload that have a finite lifespan, such as data processing or machine learning. So for such workload, a tool to manage it to overall process is sometimes very essential. In the case of ECS, as you can see in the screen, it can easily integrate with Amazon managed Apache services, event bridges, batch, or AWS Step Function to build robust workflows. So for instance, if you need to run your application a Chrome basis or one-time schedule, then you can leverage Event Bridge with AWS Fargate. But also, by integrating with managed orchestration system like AWS Step Function, you can fully control workflows with performing parallel tasks, building decision trees, and this would be loosely coupled workflow. So that's all for ECS Fargate explanation.
Thanks, Juyang. All right, I'm going to start with different patterns. Eric, I know you're going to ask some questions
I have
here.
stuff. Yeah, well, I have stuff to say. Like I said, this whole topic excites me. Because I'm kind of new to it. But let me ask you this, and Uma, tell me if I'm stealing your thunder here. But well, you know what? Present a little bit, then I'm going to throw my statement out, okay, or throw my question out. So tell me what to do, because I don't want to steal your thunder. So go ahead. I apologize.
No, feel free to ask question. I do want this to be more
I do.
interactive.
I feel I just throw them out there. But what I will ask is, Juyang, something to understand, and I didn't understand this about tasks, and I want to kind of explain this before we jump here. A task is not a one-to-one to a container, right? A task can have multiple containers, multiple things going on in it, correct?
Yeah, you got that. So I couldn't explain it some in detail, but ECS task is the smallest execution when it comes to ECS cluster. But like Eric said, we can include one or more container image into ECS task definition. That being said, if you have a main application and then there is a sidecar or another container can be included in one ECS task. So it just really depends on the customer taste. But yeah, that's the correct, Eric.
Yeah, and I think that's interesting because as Uma's getting ready to show here, and again, I don't want to steal the thunder, but we bring this up. It's not just like I come from a Lambda world, right? I mean, I only build in Lambda, or I have been only building in Lambda, and Uma's laughing because this is the conversation we have a lot. She goes, it's not the same in containers, Eric. But in a Lambda world, it's a one-to-one. Everything you're going to do is in that one Lambda function, right? Or when we invoke a Lambda function. But with a container, I may say, look, here's my primary app. Here's my logging. Here's some stuff that's dependent on. I may have 3 or 4 different things going on that could come up and come down. And so it's a nice isolation. It's a nice way to kind of build those out, break those out, and think through it. So, all right, I'm going to stop there. Uma, all you.
Yeah. All right. So people who are familiar with step functions might have heard about 3 different integration patterns, right? I'm going to show 4 patterns. Actually, there are 5 patterns. I'm not focusing on the 5th pattern, which is the API pattern. This is going to be mostly like data processing kind of workload related conversation. Juyang talked about standalone tasks. That's where we're going to focus today, not the API part. And so the first integration pattern is a request response pattern, where it's it's an implementation, I would say, like on top of how the SDK behaves. So if you use an SNS publish, it's basically an asynchronous invocation. SNS publishes and then it goes again, does something. So this particular pattern invokes a service, and immediately after getting the response from that service, it just moves on to the next job. So think about integrations like EMR job or a glue job or invoking a submit batch submission. All of them, when you invoke the API, it immediately gives you a response, but then behind the scene, they will go ahead and complete that task. But when you invoke the Lambda invoke, actually, it doesn't immediately return, because Lambda invoke API will actually complete the Lambda invocation and send the response. So it's not like triggering a Lambda with event method. It's still a request method. And so it's in case of Lambda, it's a little bit different. But when you use it with ECS run task, it triggers a run task API and immediately returns. And the way you specify that by providing this information, the AWS SDK ECS run task in the resource. And so if you want to actually do something or like find out whether this task is complete before we move on to, then you have to do the polling yourself. You have to invoke the described task, find out whether it is complete or not. And I have a very, very simplistic example here. That's not how you would implement. You should have a wait loop actually to check whether it is this done or not. But actually, doing that is not necessary, because we have this optimized integration. This is a very popular pattern. Do this pattern only if you want to move ahead immediately after triggering a task. You don't want to wait and you want to just go on, do something else. But if your workflow needs to wait for the task to complete, you should be using this integration called optimized integration. And in the optimized integration, you see the difference is like the way the resource notation is defined. You saw earlier it was SDK. In here, it doesn't have anything. But the rest of the parameters, like how you pass and what kind of VPC it's going to be, and all of that will be the same. And so the difference here is Step Functions automatically finds out when the task is complete and tells you like this job is complete, and then you can move to the next step. That's the magic that is done at the Step Function side. Some a few things that you should be careful about when you were doing this. One, you will pass the payload in the container overrides because you're calling a run task API. In the run task API, there is a parameter called container overrides. I think I have an example later in this later slides. And there you will be passing the payload. And container override has a limit on how much you can pass in. And Step Functions has like 256 kilobytes. In container overrides, I think it is about like 8 kilobytes or something. So if you have a larger payload, you cannot use that way to pass the payload. You might have to use an external store like S3 to pass the payload. So something that you should remember. And then the other thing that you should remember is when you are actually running like multiple run task, right? Either this Step Functions is invoked like 100 or 200 times and it's all running, or this run task is being called from other places. Basically, you have so many run task integration that's happening. So what happens at that time, there's this, in order to figure out the task is complete or not, Step Functions uses describe task, and other applications might also be using the describe task. So what happens, the describe task API limit can be, that will reach, and so you will see throttling. If you're noticing in your metrics, then you will see throttling of the describe job. So what you should be doing, there is a workaround for that. If you are running like hundreds of run tasks at the same time, you are getting into that problem, then you can remove the describe task permission from the execution role. So how does the Step Functions invoke the ECS? Is like it invokes the API, which means it needs permission. It needs permission to invoke the run task API. It needs permission to invoke the describe task API. So if you remove the describe task permission, it will not call the API. Then how does it figure out whether the task is complete? It also falls back to another mechanism through which it infers whether the task is complete. That is through EventBridge. You know that ECS is well integrated with EventBridge. There is this task events go to EventBridge, service events go to EventBridge. And so Step Functions will listen to the EventBridge task event to find out whether the task is complete. This particular, if you're looking at if you are using this eventing mechanism from services, there's some services give you best effort, some services give you durable. And so I believe the ECS one is durable. So you definitely will get that notification, but it might take a little bit of time. So if you have described task permission, it will immediately find out whether the task is complete. If you're removing it, it might take a little bit of a time to figure out your task is complete. So it might take your ECS run task might not move to the next step until that event is reached to the event bridge and to the Step Functions. That's another thing you should be remembering.
Hold on. I'm going to interrupt you for a minute here, okay? So if I understood you correctly, right, I'm telling it I want to describe the task, right? So I get the answer as I'm polling. Are you done? Are you done? Are you done? Are you done? I've actually never heard of this. This is really cool. Now, if I remove the permission, then I'm going to call it but fail. And so then I fall back to looking at EventBridge notifications. And that's just out of the box, right?
That's out of the box. That Step Function does it. You don't have to do it.
Okay, that's really interesting. That's an interesting. I have nothing else but to call that a hack. That's really cool.
It is.
So I'm going to interrupt you, Alva. We have a couple questions. Well, we have one question come in. First of all, we shout out to Ben Smith. Ben Smith says, "Hey, everyone, this is great stuff." So yeah, we love Ben. Ben used to be one of us, still one of us. We love Ben. He's a Step Functions genius. So good to see you here, buddy. We have Daniel, of course, coming in. Daniel is one of us, and fabulous out of Brazil. Now, the question, Alper, who we know Alper, he says, is it, and I believe he's referring to ECS, is it fully managed or partially managed? i.e. task definition, managing memory, CPU, networking type, etc. And I'm going to ask Ji Young on that one.
Yeah, based on my understanding, his question is more about the Fargate. So when it comes to Fargate, you have to specify a CPU and the memory resources into your ECS task definition. But when it comes to ECS EC2, that is optional. So it really depends on the which computing resources are you going to use. And then networking type, when it comes to Fargate, only AWS VPC mode is supported. So what that means, host mode, bridge mode is not supported. That is for the ECS EC2. So yeah, the fully managed means we AWS managing the infrastructure layer that is under your containerized web application. So that would be the good explanation, I think. So let me know if that is not enough. Happy to follow up.
That was beautiful. Thank you very much. All right, Uma, I'm gonna turn it back over to you.
Yeah, cool. There is another concerns that I hear from concerns asked from customers is I want to get that response from the run task, whatever the container is running or outputting. I want to get that and pass it to the next task. It's not
And this won't
possible.
do that, right? This current model will
Yeah,
not do that,
it's
right?
not
Okay.
possible.
Yeah,
Yeah,
yeah.
because we are actually calling the API and then calling
Mm-hmm.
the scribe task to find out whether it is complete. So that API itself does not support that. The only way you have to do it is to store it externally in S3 or maybe DynamoDB and pass that information over. There are other ways, and I will talk about it. To maybe if you do want to return and you don't want to use an external store, there is another integration, which is what I'm going to talk about next, which is callback. And a lot of people here might be familiar with the callback integration because we might have used it for approval workflows, like human in the loop kind of workflows. The way callback works is it gives you some kind of a token. It gives you, in the sense, gives that service, which whatever that is integrated, a token, and then the service goes ahead and do it on its own. Let's say if it's an external third-party API or maybe a human in the loop, they will just go ahead and finish that task. I mean, they might take even up to a year, 365 days. It just waits. It just passes on that place. And when the job is done, you will send that notification back saying like, I'm done and here is this token, and then Step Functions resumes. That's the callback integration. And you can use that callback integration with ECS as well. And what does it give you extra? It gives you a way to send back the response, send back granular error messages so that you can make some decisions in your workflow to move across like different flows, right? The way that you will do it is, again, the same resource. Everything else is going to be the same. You're going to say, I'm going calling run task with wait for task token. And then you have to pass this token. When you designate that any task with the wait for task token, Step Function automatically knows, okay, so this is a callback integration. I need to pass it. I need to generate a token for this task. So it has the token, but you have to use the token. So here you can see that I'm using that token to pass in as an environment variable to to my ECS task. Right. So once I pass this, what happens is so when service calls this API, and then we'll wait. It just goes to the wait state, and then on your API, sorry, on your container, you have to actually use that token to return it, right? You will process this message or whatever data processing that you need to do. At the end of it, you will send back this token along with information that you want to send back, whether it is failure or success. You can go as granular as you want. And so that is the advantage. But if you look at it differently, that might also be a disadvantage for some people, because now not only your step functions is coupled to the ECS, and your ECS container is also coupled to your step functions, right? And your container has to have the knowledge that I am going to use this token. I'm going to call this ECS API, which is the send task success API or send task failure API, in order to ensure that this whole process completes. So there is this coupling it increases the coupling in a way, right? However, it gives you much more control, and also you don't get into the described task limit, throttling issue as well. So those are the advantages with callback process.
So can you go back a slide real quick? I want to kind of show something here. The other thing to understand is we gave away a future slide. Sorry, that was on you. So in this environment, this is also how you pass data from the step function to the container.
Right.
So you may have some data. You may say, hey, here's a video on an S3 image or S3 bucket I want you to process, or here's whatever. And so this is how you would pass that over, and then obviously you send that back. And I like your explanation of the coupling. You're right. It kind of couples those up. The nice thing is that if something were to fail, so this is really honestly, this is where you want to, heartbeats, timeouts, those kinds of things in step functions. So you want to understanding that they're coupled and that we don't want to lock up our step function or our workflow. If something else fails, then we're going to put in the timeout. And we're going to put in heartbeats to make sure that those are still going. And so I just want to call that out real quick. We also have a question real quick here. I told you I was going to interrupt you. So this is coming back. Jan Richter said, hang on just a moment here. There we go. Well, we have two questions coming in. We said, regarding the ECS describe task fallback to event bridge, is this true for other API SDK calls as well?
Not all the tasks. For example, you can do it for glue job, I believe. And see, but you cannot do it for EKS because EKS doesn't integrate with event bridge. You don't get, or actually, I have to take that back. Does not send the task or pod completion event to event bridge, so you cannot use it for EKS. I'm sorry, I did say that we will also be going over some of the EKS nuances of like how it integrates. I did not. So for the request response, it's going to be very similar when you're calling EKS. You can invoke it, the pod runs on its own, and it will just step functions move on to the next step. When you are invoking with the wait for a callback, sorry, not for the sync integration or optimize integration, it's also supported. However, there are a couple of nuances. One, you can't actually remove that describe permission because I mentioned about the event bridge not receiving that event, or the event is not available. The next thing, the other thing is today, step functions can only invoke an EKS pod that is running in an EKS, which is public, has a public API server. If your API server in EKS is private, you won't be able to invoke that. And so that's today is how it works. So that's another nuance with EKS.
All right. So I got another question here. This one's coming from Alper. Task token equals you're limited to standard workflows, and I'll jump on this. I know this one. Yes, you're right. Task token is something that is in standard workflows. If you're not familiar with what that means, if you're watching this, there's two type of executions you can do, or two type of workflows. There's standard and there's express. And there's obviously a price difference. Express is cheaper, but it doesn't offer all the same features. So if you're going to use task token callback, you do need to use the workflow or the standard workflow. And then we had another question come in, and I could probably answer this, but I'll leave it to y'all. This is there any ECS sidecar pattern solution that handles the callback for you? For example, if container A is finished, container B will hit success.
I don't think AWS does not have an out-of-box ECS feature for like automatically handling callback between containers. Yeah, so but we have some of the parameters, something like start timeout. So if A is successfully complete or becoming healthy status, then the B container can be started. So those function came across my mind. But when it comes to callback, I don't think there is a out-of-box feature.
All right, beautiful. All right, we'll stop interrupting you. Ji Young keeps interrupting you, so go ahead. I got you.
Okay, the last one pattern, the fourth pattern is this step functions activity pattern. Not many people know about this activity pattern. And activity is, Eric is nodding his head.
All
Yes,
right,
we
now
know
I'm
about
interrupting you here.
it.
Okay, so let me wrap that around a little bit. And they've chosen to mow right outside my window as I'm talking. So here we go. We'll deal with that. But yeah. So the first time, and Uma's going to explain this pattern to you in just a minute. The first time she explained it to me, and she explained it like, well, there's the activity pattern, and you do this and that and that. And I literally was like, what? I had no idea what she was talking about. And to be honest, I don't want to toot my own horn, but I'm pretty good at step functions. I'm not Ben Smith, but who is, right? But I had never heard of this, and I was like, whoa! So, wow, them go.
Yeah. And I don't know. I think it's because this is one of the oldest feature, and it is also a feature that requires polling. And a lot of us are like really lazy. We push. We're more used to push mechanism. That's probably is another reason it's unnoticed. But anyway, step functions
So
activity.
what I just heard was, Eric, it's been around forever, and you're lazy. That's what I just heard there. Anybody else pick up on that? So, all right, I'll stop interrupting.
That's true. That's true, Eric. All right. So, activity is a type of resource in step functions. And so you will create the activity first. And after you're creating the activity, you can use it in any of your workflows. And when you use it in your workflows, you will send the message to the activity, and the activity will keep that message until somebody consumes that message. Think of like a queue, right? So in a queue, your producers are like your workflows. Your producers will be sending information, sending messages to the queue, and there should be consumer on the other side of the queue until then the messages remains there, or until that retention period comes off, right? It's a very similar mechanism. And so when you use activity in your workflow, that messages get sent to the activity is a resource. It's like, I really don't like this name activity and activity, but that's how it is. So you send the messages to the activities. And the other side, you can have a container running in ECS, run a container running in EKS, or you can have a virtual environment on premise, or it could be your local desktop. Anything can consume from this messages. That's how step functions integrates. That's one of the ways step functions integrates with like containerized environment on premises, right? And so the only permissions that's needed on the worker side, it should have permissions to consume the messages, which means it should have the step functions API to get the activity task. And once the activity gets processed in the worker, and the worker will send the token back. It's basically a very similar mechanism as a callback, where when you consume a get activity task, when activities, you will also receive a token. And then once you process the message, once you process the activity, you will then send the token back. And so it's a very similar to callback token approach. You can have one or more consumers, and it's totally up to you how you are processing messages on the other side. I really love this pattern because it gives you a lot more resiliency to your workflows, because you have a queue there and you just keep sending the messages. And you can also, when you're using containers, you can also leverage spot compute, and so save cost with this pattern.
Yeah, I think that's an important call out right there, and something I was going to call out as well. We were talking about overwhelming the run task API, right?
Mhm.
And the run task API is not designed to be hammered like the Lambda service, right? The Lambda service is designed to scale and handle all that, but the run task is more designed for one-offs or multiple things like that, but not to just be here's 1,000 tasks, go for it, right?
Yeah.
And so so I think that's an important thing to distinguish, because if you're going to have something, and a great example is last year we built the serverless video project that we showed at reInvent, and to kind of show that video can be done with serverless. And one of the things we learned is that that, all these videos coming. We were all streaming from all over the place, right? And the Lambda we had Lambda processing these, and when we were in testing, we realized as these videos get longer, it was kind of bumping up against the timeout for Lambda functions. Okay, so what do we do? Well, that's when I learned about event-based containers. There it is. I used it. And the idea here is these containers would happen. The container would come up, do the work, and go away. But what we don't want is that for them to we didn't want to send thousands at a time. So we were able to say, we actually wrote into the step functions, we did it by the length of the video. If the video was longer than 20 minutes, do the processing in a container. If it was shorter, then do it in a Lambda. By dividing those substrates to kind of say, okay, like you have ECS available, you have containers available, or you have Lambda functions available, we were able to balance that very nicely. So we'd come up on ECS once in a while, and the Lambda just, going crazy as needed. Now, I do have a question for you. So when you say start, so you were explaining, you should say, first of all, you start an activity, you create an activity. What does that look like? And I want to, cut into our demo time, but is that a separate state machine that you're creating? Is it something in, what is there something in that I say in the step function console that says start activity? What does that look like?
I'll show you in the demo.
Okay, then I'll stop talking. How's that?
You stole my thunder. I was going to show this run task. You shouldn't be.
Oh man!
You stole my thunder.
I'm just, I'm full of knowledge, Uma. I'm full of knowledge. So, all right, I'll be quiet. You go ahead.
And so, just like Eric said, if you're, for example, processing invoices, and if this comes like once a minute, or like one task that you're running, or maybe 50 tasks you're running, you should be fine. But like if it keeps coming up, you're processing on upload event of a invoice, then this is not the pattern that you should be using. The ECS run task on like every single S3 upload event, and that comes out at really large scale, is not something that you should be thinking about. You should think about activity pattern. So basically, I've replaced that the run task ECS task with the send invoice to activity task. Basically, I'm sending the activity to the activities resource, and then my ECS task actually consumes it and sends back the token. What I'm going to do now is going to share my Chrome, actually my browser, and then let's do the demo. Stop the screen. I am going to share my screen, the other screen. All right, share.
All right, I'll bring that in when you're ready. Okay.
Yes, I am in.
Right.
I'm in my AWS console. Okay. I'm opening my step functions. I believe this is the one. Let's open it up. I don't want to increase this. Eric told me not to do that. So I'm going to zoom in.
I am a taskmaster. I mean.
All right. Hopefully you see my workflow.
We can see it.
Yes.
Right. This is a little bit different from what you saw earlier, where in the presentation I showed an upload event from S3 to invoking a step functions workflow. But here, in order to show how there's like a large number of objects being sent to the activity, I kind of used another feature of step function just called distributed map. And so here I'm going to invoke just one workflow, but I still will be sending like hundreds of, like maybe thousands of tasks to the activity. And the way I did is I used a distributed map. And people who are not familiar with distributed map, it is a state in step function that allows you to run collection of, allows you to run a particular logic on a collection of objects or collection of items. And that items can come from an array from a previous step, or it can be an S3 object. In my case, I have like collection of CSV files in S3. You can see that, not this bucket. And so this is my bucket, and I have, I believe I have about 500,000 CSV files here. In my workflow, I'm going to process it through distributed map. But all I have inside my distributed map is the step functions run activity. And so if I go in here and you see what I have, it's just an ARN. And I'll open up here and you see an activities on here. So when I open it up, you see here, there's this activity. It's nothing but, it doesn't have anything. You just have a name to it and there is a tag and you can encrypt. That's it. And so it gives you an on. That's what I'm going to use. So there's the activity. Actually, the distributed map sends all of the different CSV objects from S3 to the activity. And then the other side of the activity, I have ECS. ECS tasks consuming as workers consuming this message. Because this is batch, I don't want my ECS task to be running. They are not long running. They're just going to be created at this moment, and then they will be destroyed. And so what I have here is I'm invoking the scale out workers API of ECS. So I'm directly invoking it. And I'm just setting the desired count to 100. So my cluster will spin up 100 different tasks. And as the tasks are ramping up, is coming up, I will be pushing the activities to the task. And then once all of these activities are completed, I will be destroying the worker. So that's really, really simple workflow. Any question, Eric?
Yeah, we have some questions coming in. I'm still like, wow, I literally just in awe of this pattern. I love it. I love it. I love it. Real quick question here. I think this pertains here. So you have this question: run tasks will create new containers from task definitions for each call. This is actually maybe before the activities, but yes, this is correct. If you're doing run tasks, not activities, sorry. We'll come back to activity in a minute. If you're doing run tasks, then it will create a new container for each task definition. That's again why you would want to kind of evaluate. One, do I need run tasks? Can this be done on a Lambda function? Okay, and so because that's kind of where you start. And okay, well, yeah, no, the Lambda function is not going to cut this for timeout reasons, for cost reasons, for whatever. Okay, run tasks makes more sense, so we're going to go there. Now, hang on a minute. I need to run thousands of these, right? And so that it makes more sense to bring up a single container or a cluster of containers, like a task like Uma just pointed out, and run that in an activity. I don't know why I just answered that. I should have asked you all, but I got all excited about this. So, So now I do have a activity question. Alfredo, I hope that answered your question. So here's one. It says, does the activity consume state machine transitions, or does it count as one? I'm wondering how it affects the 25,000 limit. That's the history limit.
Yeah, it is a step, right? So, and it is a step. It's if it is part of a standard distributed map, yes, it is counted as a state transition.
And Jin Young, did I interrupt you earlier?
No, it wasn't. I mean, the thing I would like to say was that Alfredo was mentioning about a setup task equal ECS service, but let me a little bit correct that one, because when you create an ECS service, then it trying to keep the desired number. So it's when it comes to like a standalone task, you can provision multiple about the single or standalone the task, but it's a little bit different with the creating ECS service, because service is more about like a front end or back end service, and it's keep going on running again and again. But when it comes to our data processing, everything is done, then it will be terminated. So it's not a equal concept about the service. So yeah, I just want to correct that one, but that's all.
All right, good call out. I don't want to make y'all nervous, okay? But I just recognize we are in the presence of greatness. Just so you know that I'm going to put this up on the screen. Mr. Grant Lammy himself is observing this show. Now, if you don't know who Grant Lammy is, he's a step functions guru, National Children's Hospital. He has helped bring them a long way. They're doing amazing things with step function. They're helping, identify cancer. They're doing a lot of different things. But he points aside, it's not yet mentioned, the power of step functions, retry, and back operate with ECS batch and EMR. Serverless cannot be overstated. Just yesterday, it saved our bacon. We didn't fail. even in an S3 outage. So some really cool stuff. And this idea here, just to kind of throw this out there, this is called building for resilience. Werner Vogel said everything fails all the time. It happens. At AWS, we build for things not to fail, but we plan for them to fail. That's just the way it happens, right? So we build in ways to build resiliency, to build retries, to build backoff rates, to build catches, and all those kinds of things. So great to see you, buddy. Thanks for the call out, or thanks for the, wasn't really a call out, but thanks for these wise words of wisdom. So, all right. Looks like you got your clarification from Alfredo. We cleared that up. Good to know. So another question here. Whoa, it's very busy this morning. If using distributed map for processing in batches that will not exceed Lambda timeout, why not use Lambda directly?
The question is if the activity or whatever that runs in that process can run within the Lambda timeout, why not use Lambda?
Yeah.
Absolutely. I will use Lambda. Yeah.
Why not? I think the thing you evaluate on that, though, is where's the cost break point, right? If I'm doing tons of them, I'm bringing lambdas up and down, or if I can have 2 containers out there processing and then take them away, you really want to look at those price points, right? But yeah, that is a great question. Why not? That's my go-to, right? Actually, step functions is my very first thing. I make step functions first always, and then lambda functions, and then when it doesn't work at a lambda function, then I go to ECS. Kind of how I approach. But that's a great question.
Yeah. All right. So let's actually run. Okay. So I am being stupid here. I'm sorry. So it looks like the one that I ran yesterday didn't actually finish. So what I'm going to do is see what failed and then work backwards from there. So it looks like
troubleshooting online. I love it.
We scale the workers, which means my task has been running for more than a day and it's incurring cost in my account. And so let's go to the ECS and let's check it out. And I'm looking at the task and you see, I do see my task running. So all my 100 tasks are actually running because I didn't destroy the worker and the distributed map failed. Right? I know why it failed actually. Let's look into it. So because it says the exceeded tolerated failure threshold. And so let me click on it and open up this page so that I know more about why it failed. And I'm looking at it and you see that there's, actually there are 600,000 objects and 500 objects are processed and 400 failed. And because they failed and the other stuff are botted, that's because I didn't set the tolerated failure. So that's an important factor about when you're using distributed map. Distributed map allows you to control the concurrency. That's I'm actually sending 1,000 tasks in it. It also gives you batching ability, but it also gives you an ability to say how many of your tasks can actually fail. And do you want to proceed further even if it fails? And that's a very important one and I believe for data processing jobs. Sometimes you don't want to fail your entire workflow because like 10% or maybe 5% of your data is not up to the quality. And so in here, if I had set that percentage, this workflow might not have failed. So what I want now is I want to restart everything. No, I don't want to restart everything because it's 600,000 objects. So I am going to restart only the ones that actually failed and aborted, which is 85,200 objects. So I can use this feature called redrive from failure. This came up, which is last year around the re:Invent time. So when I do that, it doesn't actually restart the entire workflow. That's like too much to do. Like I would be processing 600,000 objects again. So I want to process only the ones that actually fail. So I'm going to do the redrive. Hopefully
that's
this
not
works.
idempotent, is it, Uma?
Because it failed, yes, you don't know at what stage in your code it failed, right?
Exactly. I was just
And
using a big
so,
word though. I'm saying that's not
yes.
idempotent. Yeah, I just wanted to
Right.
impress you, but apparently that failed. So, all right, go ahead.
So now what happens is all my failed ones, 85, 200, are running, and they will be getting processed in my in the task. All right, so you see something's happening. Some of
They're
them
going.
getting provisioned. Um, and so hopefully they'll get processed. Okay, so all of them is running quickly.
Mhm.
So I can process, that's the beauty of distributed map, right? I'm actually processing 80,000 CSV
Yeah.
files at the same time in parallel. I have only 100 tasks, and I send all of those 80,000 into the activity resource. And on the other side, my ECS task is basically consuming all of them.
Mhm.
So it's going to take a few minutes, maybe a minute or two to complete everything. And when it destroys, I do want to restart. I hope like we have time, like we have 10 minutes, right? I do want to
Yep.
restart and show that new tasks are getting provisioned.
Okay.
Yeah.
All right.
Um,
So while we're doing that, I'm going to bring this statement up here. We also, I didn't know he was in here, but D Raj, I call him Master D here. D Raj Mahapatra. I know I destroyed his last name.
Captain D.
Great question about you. What's that?
Captain D.
Captain
He's,
D. There it is.
yeah.
Yeah. Great question about using Lambda functions. However, another aspect of using activities is bringing existing workloads, maybe running in ECS to orchestrate data processing on SFN. Very powerful feature. Yeah, Duraz does a lot of work around existing workloads and bringing event-driven architecture into existing workloads. He really is the captain of this and has done some great work. And this is a really good call out. We tend to think greenfield all the time. Hey, I'm building something brand new. But the reality of enterprises, the reality of most people is, hey, we've got this built. We want to do these modern applications. We want to get into event-driven architecture. We want to use serverless, but we can't just, take, hey, we're going to shut down for a year. Go ahead and keep paying us. It doesn't work that way, right? And so this idea of kind of rolling these features into existing workloads is a big deal. We have another question coming in here. Says, is there an example for repo for demo for the demo Uma's showing? Do you have a demo? Do you have an example repo? Is that in
Yes,
the
there is.
links?
Yeah,
Okay.
I did write a blog last year. I gave you the link, Eric. Maybe like you can
Is it
post
the
that link.
DMAP activity CS?
Yes, it's a blog
Okay.
link. Yes.
Yep. All right. Yeah, I posted earlier. I'll post it again here, real quick here, Jen. Hang on just a moment here. And yeah, watch for that in a few moments, and then we'll take this out and let Uma continue.
Yeah.
All right.
And so I just wanted to show this activity. Here it actually passed. And I was, we didn't actually look into why it failed. In fact, it failed because of the timeout seconds. It actually breached the timeout second. Eric mentioned earlier, when you were using long running activities, it's very important to not long running activities alone, long running tasks. It's important to tell when to time out. And so this particular attribute tells like it times out like after 3 minutes, or if it didn't hear a heartbeat after a minute. So my activities failed because of that fact. And you know why actually it fails? I don't have a elaborate error here, but however, what happens is I send like 80,000 to 90,000 activities
Mhm.
over to the ECS task, and I'm consume them as batches. So what happens is in the code, it actually writes to S3, S3 put is actually reaching that limit. And so it takes time to ramp up. And because of that, it resulted in timeout.
All right.
Okay,
So,
so and
real.
here, go on.
Oh,
Sorry.
sorry. Go ahead.
No, just go on. I just wanted to go back.
Explain a heartbeat real quick.
Oh
So we
yes.
talked about heartbeat. Yeah.
Yeah. So there are two attributes. Let me go back here. Defined heartbeat and also timeout second. So both tells the step when to actually time out. And timeout, it should be the bigger of the two. So heartbeat should be less than the timeout. Heartbeats typically is your long running workflow is going to it has to send a heartbeat. So there is an API called send heartbeat, step functions API. So your long running a workflow, or sorry, long running task will be sending every 60 seconds a heartbeat API to Step Functions. And when it sends it, Step Functions know, okay, this particular job is alive and it's still kicking, and I shouldn't be timing out. If it doesn't send it and you still have the heartbeat second at 60, then it will time out even before the timeout. And so you should in my opinion, you don't want to define heartbeat second if it's not a really long running task. For example,
Right.
some might have like approve human in the loop kind of task, right? And that might take like maybe uh a few days, or there might be
Like
jobs that
it's
takes
really
like a
chatty.
few weeks, right? And in
Yeah.
those cases, the workflow is just paused, it just waits. You're not charged for it, because if you're using a standard workflow, it's only charged for the state transition, but it just basically waits there and it doesn't know what's happening. And that's when you will use heartbeat as saying, oh, this particular process is in maybe a reviewer process, this particular process in some other step. And when you send this heartbeat to Step Functions workflow, it knows that, okay, so this process is still alive and I shouldn't be timing out. And so that's when the heartbeat is used. For a smaller task like this one, you don't really need to send heartbeat. You have to, if you're using heartbeat, you have to use that API to send the heartbeat to Step Functions.
Yep. All right. And hey, don't worry about going over. We're not on Twitch this time, so if we go over a little bit, it's okay.
Oh, cool.
So yeah, so too. That's not carte blanche there. Almost like, well, I got another 2 hours of stuff here, but yeah.
All right. No,
Yeah.
hopefully this is getting processed. You see, it's slowly getting processed. It's not like Lambda. I know that.
Well,
But
you
it
say
is.
slowly, but that's the 80,000 of
Right.
them have been processed already. So I mean, that's
Yes,
crazy.
exactly.
Yeah.
Right. Yeah. I don't think I have the code here. It doesn't do much. It's actually the Monte Carlo simulation blog that I wrote, but
Okay, gotcha.
that
Okay, yeah.
didn't have much logic in there. It does some random thing there, but it iterate on it and put something into an S3 object. And so it's not a hello world, definitely. So there is some process that's going on.
Right. And you're managing that across 100 instances. Is that correct? Okay.
Right. It is
Okay.
across 100 instances. So if I go back here, and I look at the scale out workers. So I set the desired count to 100.
Okay.
Um, and so it'll be 100 tasks that's running. We can check in the ECS here also. So let me see. That should be 100. I don't know how to. Oh, so there's 4.
You have test one of 99. So you have
25.
99
Yeah.
tests running. Yeah.
Right. Yeah.
Yeah. So that's pretty close. All right. So in this, just kind of, I'm going to dumb it down for me here. So basically, go back to your workload if you can.
Uh-huh.
So what you've done, you've got your activity set, right? Your activity's already created off somewhere else, right? So in
Yes. Right.
here, you now said, okay, my activity points to this cluster. This
Mm-hmm.
is, or this, I guess it's a task you're doing. So what you said is, I know that activity is going to be big and need a lot of stuff. So I'm going to make this step before I start dropping things into my activity. I'm going to up the task count on there. That's what that one is right there. It looks like you failed again. And then once it comes down to the once it's done, then it'll bring those back down.
Mm-hmm.
Okay, gotcha. And are you going back down to 0?
Yes, it will go back down to
Okay.
0, because in the workflow, if you look at the final step, actually,
Okay.
we should go back here. Look at our definition, scale out workers, and where was our just
There it
try
is.
workers here. a desired count is
Desired
0.
count. Yep.
So when you're running it as a standalone task, you can have your cluster without any task running, right? So that's a real cost savings when you're running it for batch executions. And so
All right.
it looks like we have failed again, and I believe that's because of that. So still there is for 4,400. So let's take a look at it. I believe it's only task timeout. It's one task fail. I should have set the failure task percentage. You see, that's it again timed
Yeah.
out. Yeah,
Yep.
it again timed out. So so I'm going to go back and
Let's
retry
finish
from
those. Yeah.
failure. Let's finish it up, and I hopefully this time I won't have problem with S3 put object.
Okay. So let me ask you this. Let's talk about the failure and dealing with that, right? So we started with 595,000 events, right? So a percentage. The reality of life is some of those are going to fail. That's how data.
Right.
If you've been doing this very long, that's how
Right.
it's going to work. So there's a couple things we can do. Obviously, you tune it. You can up your failure threshold, different things like that to handle more failure. And then you can redrive those, or you can see like that. But kind of a cool thing here is I'm assuming, and you tell me if I'm wrong. I'm assuming that I know this. The failure is getting kicked out into CloudWatch, right? So I can actually trigger off that failure, and I can start a redrive as needed.
Yeah. You can do that as well. So there's there's another way you could actually do it. Like you said, the redriving part. So in here, I'm actually going to go to this one and edit the state machine. There is this feature of distributed map that allows you to export the results of the workflow into a place in S3. And so that will aggregate all the success as well as failure. Failure will be in a separate JSON file. And so what you can do is, and once your workflow is complete, and you take that failure, if it's failed, and you can look at it gives you the location of where your failed objects, and you can use that to trigger or redrive your workflow. That's another way to do that.
Okay.
Right.
So you could catch these so that your workflow finishes eventually, right?
Yeah.
So we could catch that, and then we say, okay, once it's finished, give me a report. All right, this is a success. This is the fail. All right, now redrive those failures.
Yes, you can do that way too. Yes.
Beautiful.
Exactly.
Beautiful. Okay. All right. Well, we need to wrap up.
Yeah.
So, any shameless plugs, Ju Young? Do you have anything you want to throw out there? You got any reInvent sessions going on? Anything you want to talk about?
Not relevant with this topic, so I don't want to.
You can do any topic. This is your shameless plug moment. So yeah.
Yeah, I mean, for me, I'm going to deliver some session like how can we integrate Gen AI workload with the ECS package. So yeah, anyway, that's the thing. But I feel like Uma and then Eric, you guys are definitely do some breakout session really well relevant with today's topic, isn't it?
That's right. Right on this topic, yeah. And I've tweeted it out already, so you can follow that. Included and I, but yes, we have a topic where we're going to be talking about building containers using or building event-driven architecture with ECS on Fargate. And Uma is the brains. I'm the laughter, I guess. But we're bringing that, and it'll be a lot of fun. It's some really good stuff. Hopefully, if nothing else in this session, you'll see that both Ji Young and both Uma top-notch essays. If they have a session, you want to catch it. You really do. And so Ji Young has been fabulous on helping me catch up on containers. Uma's always teaching me something with Gen AI and step functions and life, so I really encourage you to catch either one of them at reInvent. I also I have 5 sessions at reInvent, so I'd love to see you in one of them. With that, we're going to say I'll see you later, and if there's anything else I need to put it there.
Actually, I wanted to show that this workflow actually completed. You see destroy workers, and then there is no ECS task. All of them gone.
Nice. Scale to zero, event-based containers. There it is. Super exciting. All right. Well, with that, we're gonna go ahead and end the stream. Thank you so much, everybody, for joining us. We are here every Tuesday, same time, same place. We'll be back on Twitch next week. And with that, we'll see you later. I'm gonna go ahead and end the stream. But Uma and Ji Young, this is where my guests usually sing.